Cool. So I'm giving this talk that Garrett made me give. No, I'm just kidding. Called From Ruby to Erlang. An unexpected journey, the unexpected journey, I don't really know. So what it really is an experience report. We're going to tell a little story about an application that was built in Ruby and that we moved to Erlang, and like kind of just what happened, the experience we went through, the things that we had to build, the things that were already there. You can kind of treat it like a survey of computer science course. I can't really get like super in-depth into everything, so it's going to be like really fast and quick and dirty. And you get into these situations where you give a talk later in the day where somebody's already talked about QuickCheck and you had slides for that, or somebody's already introduced OTP and you had slides for that. So when it gets boring, you can just boo or something. So just quickly, a show of hands, how many people here are actually Ruby developers? And without lowering them, put them back up. How many of you, like, put your hand down if you're not an Erlang developer? Put your hand down if you are an Erlang developer, so I can see. All right, that's better. Yeah, I didn't practice this ahead of time. All right, cool. All right. Let's move along. All right, cool. So yeah, so check this out. So Garrett kind of changed my. Is he even here? Is he here somewhere? No, he's not. He doesn't even see it. Jesus, somebody vine it or photo it. So Garrett. Garrett wanted me to give a talk, and he says, this unexpected journey thing. I've never seen The Hobbit. I've never read The Hobbit. I've never seen Lord of the Rings. I've never read Lord of the Rings. Come at me, bro. So I don't really know anything about it. So I'm gonna try to kind of work in some plot twist at the end, because maybe that has a plot twist, but we'll see where it goes. So anyway, who am I? So C Meiklejohn on GitHub, at CMick on Twitter. It's usually just like quotes from The Wire or like vines of me doing Madonna karaoke at a New York bar. You can choose if you want to kind of roll with that. So what do I do? So I work at Basho Technologies. I'm a JavaScript and Erlang engineer there. In case you're ever wondering what it's like to work at Basho, it's kind of just like this, basically every day. We're hiring. You should come work with us if you like Erlang, if you like JavaScript, and you want to build web UIs or cool distributed databases. You should get in touch. I'm also a grad student at Brown University. I study formal verification and some distributed systems related stuff. And I run this really cool podcast called Think Distributed, which you should all check out, where we talk about distributed systems problems like consensus, consistency, all sorts of really hard topics, depending on who you are, I guess. Cool. So what did I do? So I started at Basho almost 2 years ago. Before that, I worked at Swipely in Rhode Island, which was a payment marketing startup. I was a Ruby on Rails developer there. I did a lot of Ruby. I did a lot of Rails. Did a lot of non-Rails, Sinatra, all that good stuff. Cucumber, RSpec, all the good things. And I did not do any Erlang while I was there. So Erlang came afterwards. I actually didn't learn Erlang until after I had already started at Basho. And I am also kind of a lapsed maintainer of rubygems.org as well. So I was pretty involved in the Ruby ecosystem for a while. Where is Michael from Braintree? There he is. Yeah, so funny story. I was at a Ruby conference 2 years ago, and he was sitting in front of me, and he submitted a pull request to rubygems.org, and I was sitting behind him and watched him and reviewed it, and +1 and merged it. So it's cool to see us both at an Erlang conference now. So that's really awesome. Anyway, cool. So we're going to tell a story for kids. The story is going to be about a Ruby on Rails application that we built at Basho, that we prototyped really quickly. We thought we could prototype really quickly in Rails. We had an application we just wanted to kind of get out and kind of feel it out and see what it how it worked, and then and kind of take it from there. So this is what the application looks like. So this is a management panel for React.cs, and it's kind of like a JavaScript application written in Ember.js. The backend was written in Ruby on Rails originally. React.cs is our cloud storage product, so it provides a layer that sits on top of React that has the S3 API, so you can run your own S3 in your data center. And basically, what the Ruby on Rails app does is it acts as just a proxy to the React CS instance. So it makes requests to pull back some user data, shows the app, collects some statistics on it, allows you to create users. So it's like a very, very slim layer that provides like a REST API that then talks to S3, because the S3 API, if you ever worked at it, it's not like really RESTful. You have to, sign requests. You have to use a certain utility that requires like generating HMAX and doing all this stuff. So this was just to kind of provide a nice API for people to work with. And, the motivation to kind of move it to Erlang was, we liked the idea of it. People showed interest in the product. So we decided, we're mainly an Erlang shop at Basho. So we would take the product, kind of rewrite it in Erlang, package it up with React CS, and then we'd be able to ship that to our customers. So this is kind of the story of developing that product and the things that we ran into. So I'm going to I don't really talk about Ruby in this talk at all, because it's, we're at an Erlang conference. I'm going to assume that you understand that Ruby on Rails is basically, has like an MVC, server-side kind of MVC pattern, objects, all of that stuff. I'm not really going to talk about the VM at all, or how it's, whatever you want to say about the VM. I'm not going to say any of that stuff. So moving on. So the application story. So when setting out, we wanted to figure out, in the Ruby application, you have a series of controllers, and those have a series of views that are associated with them. And then, maybe you have models that objects that provide an abstraction over working with the APIs. Maybe it doesn't. So we wanted to kind of step back and say, well, if we're going to build this kind of this Erlang application, what's like the general approach that we want to take for building this? So what we kind of start out with, so I'm assuming, you got a good introduction to a lot of Erlang-y things today. So if you don't already know Erlang. So, we're going to kind of imagine that we're going to start with a centralized like GenServer. So just a process that's responsible for controlling all of the state in the application. So it's going to handle talking to that React backend, making those changes, and storing some information, and then giving that to the users. And then what we want to do is we want to surround that stateful process with a series of web machine, not necessarily web machines getting too detailed for right now, but a bunch of web resources that will provide the abstraction that will work with that stateful thing. So as requests come into, we can have a resource for handling information about users, maybe a resource for handling information about statistics, and each of those, accepts requests. It coordinates like whether you have access to handle those requests, to get the data, to be able to give data to the server, to return if like you've accessed a resource that doesn't exist, and then those talk to our kind of stateful GenServer here. So this is kind of a singleton GenServer. It acts as a serialization point for making changes to React. So it's making one change at a time. So it is a serialization point that is. And that's going to talk to this. So T represents truth. Wow, how categorical or whatever. So T represents truth. So T is going to be the React CS instance that we're going to talk to. So the stateful GenServer will talk to React CS. They'll ship state around, user information, stats, things like that, coordinate the changes, and then our web requests will kind of talk to that state. And, we have a couple other applications of state. If you want to imagine you have a system like React, we have another web product called React Control, which monitors React, the data store itself. Imagine that you want to, store information about the ring in React or something that's expensive to get if you do it frequently. This is a perfect place to store that. Maybe that only changes so often. Maybe you can cache it there. Really memoize it, but so this kind of serves as a coordination point for the whole app. So kind of high level, how do we go about building the application and managing dependencies? So in Ruby, you typically use Bundler or something like that to package up your dependencies, to remotely install them from places like rubygems.org. And that it kind of centralizes that. And then you use Rake around that to install your dependencies and kind of get the application running. So in Erlang, we have Rebar. There's a bunch of other build tools. Rebar is the tool that we use at Basho basically for all of our products. And this is kind of what our Rebar dependency file is going to look like. So it allows us to specify a bunch of build options at the top. So we can say, well, we want our compile files to have debug info. We want the compile to fail if there are any warnings. So treat warnings as errors. Parse transform, we won't really get into right now. And then it allows us to specify these dependencies. So here you'd see, for instance, early DTL, Evan's here, that's the library that he made. Early DTL 0.70, and then we've locked it to a particular tag. He's probably like, why the hell did you lock it to that tag? We can talk about that later. Web machine, we build it to a tag, and our cloud, we build to a tag. So when we go through this compilation process rebar, it's going to make sure that it downloads all of these dependencies at these versions or fails. Then it will do the compile. It will recursively compile all of the dependencies of those. So it's going to give you kind of a similar thing that you'd get with bundler, and using rake combined with bundler. So when we talk about this GenServer, so the GenServer for the state coordination, so that central object in the graph, we can kind of walk through what an example in this application looks like. So it gets initialized and gets some sort of credentials. This is just getting information from the application environment. We have a couple calls like get users to get a user list. We have get user with a key ID to get information about a particular user. And then in the GenServer pattern, you basically write these handle call functions. So you call GenServer call. It will call into the process that's running the GenServer, and will basically pattern match on these first things. So in the first case, we're pattern matching on the atom get users. In the second case, we're pattern matching on get user with the key ID. And then we basically, in these handle request calls, that's just an abstraction to actually make the S3 call. There's a bunch of like key stuff you have to set up, so that's all handled inside there. Makes the request. If it can get the data, it calls this format user or format users function. We'll see that these format user functions return a value that gets returned to the user. So these are pure functions. These are extremely easy to test and have no side effects. And if we can't get it, we just return error back to the user. So it's pretty straightforward. There's nothing really super complicated happening here, and it's very easy to reason about. There are certain call points in this GenServer that requests will come into. We do we do one or two operations to transform the data. One of them does a side effecty thing where it goes out and gets some values from the database, pulls them back. You have like a bunch of pure functions to kind of perform transformations over those, and then you return that data back to the user. To look at these format calls, pretty straightforward. We do this atomize thing, which converts things to existing atoms to not blow up the atom table. Steve's like looking at me like, what are you doing? And we have this append admin status, which just kind of gets a key out of the app environment and then just kind of appends it to this property list. So this list.append is just a property list, and we basically, if the key returned is the key that's configured in the app environment, we just set it to true, else false. And then the format users, pretty simple, list comprehension, just go over the list, reformat them. And converting it to a struct, the only reason we're doing this is because we are going to serialize the result in the web machine resource, which I have an example of. And that requires you have this like weird struct data structure if you use Mochi.json, which we use, which arguably isn't the greatest library to use. So, whatever. If you changed away from that, you don't have to. I'm not going to talk about Mochi Web at all right now. So to provide like the abstraction that's going to talk to that to that GenServer, we're going to use Web Machine. So Web Machine is a library that we've also made at Basher. You're going to hear a lot more about it at the next section when Sean tries to convince everybody to use it, and I'm sure you'll be convinced. And it's kind of this like functional approach to handling web requests where you have a request object that comes in. It goes through a series of callback functions that represent decision points in the HTTP decision tree, and then each of those functions can change the state, which gets continuously threaded through to the next one and influences the decision of the traversal through the graph, or it can cause the web request to halt. So we'll see an example of that on the next slide. So the request comes in on this init, and we have some context object where we're going to store some data. So here's an example of one of the decision points if you look at content types provided. So with content types provided, we return a list of two tuples of content types and then the functions to call if that content type matches. So all you have to do here is say what content types are provided and the functions that generate that data, and the negotiation will happen automatically for you. So if you make a request with curl and you say, I want text plain, and we only provide application JSON, it will basically fail, and you'll get 416 not acceptable or something. 46? 46? No, 46. 46. God, I can't keep track of all the numbers. No, So that will tell it to call to JSON and continue threading through. With the forbidden callback here, this is going to determine if you get a 403 response. So here we call this security function to determine if the user is authorized to see that. We're going to talk about that function in a bit more detail shortly. And that takes the request data in the context object as well, returns in the first parameter a boolean, in the first argument of the tuple, returns a boolean, and then threads it through again. Allowed methods, same thing. If I went to do a delete, we don't support a delete, so it would fail. And resource exists is going to be the callback that will handle if it's going to return 404 or not. So we attempt to retrieve some data. If the data is unavailable, we return false. We continue threading through. That will cause the 404 to be returned to the user. If not, we return true. But we have this interesting thing here, maybe retrieve users, which we'll talk about in a second. So a common pattern that you'll see, especially if you look at the source. So this whole two things. This whole application is open source, as well as our other web machine kind of based application. So you can go look at all of this code. I have this thing right here that's going to tell you what files. I'll put the slides up so you can go look. This is all basically the same. Some of these functions were a little bit more complicated, so I slimmed them down. So it was just easier to explain. Second, it's really cool to see slides this big. I'm like really digging the screen. I wish I had this screen. Maybe I should just work from this theater. So this maybe retrieve users. So how do we go about handling something where we have to call in? So this web request has all these functions, right? And a lot of these functions are pure functions, like this content type provided, right? So how do we go about handling something where we need to retrieve some data from the GenServer? So let's think about resource exists, right? So the resource exists, we want to determine if the data is available. So we want to call to that GenServer and we want to get the data back. And maybe the GenServer returns error and it can't handle the request right now for some reason, whatever, it's overloaded or maybe there's something else happening. It makes a request to S3 and it fails or something. So resource exists is one of the callbacks that actually needs to retrieve data from the GenServer. But later on, when we call this toJSON function, we also need to return that data again. So how do you go about handling a situation where you need to make that call to the GenServer in two places, but you don't want to make the call in two places? So that's why we do this maybe retrieve users, and we have this context object. So the context object comes in. It starts off in this init function, uninitialized with undefines. And then we have this maybe retrieve users function, which allows which we'll see on the next slide. But think about it conceptually before we look at the code, because it's a little, if you haven't seen a lot of Erlang, it might be confusing. We make a call to the GenServer. If we can get the data back, we store that data in the context, and then we pass that new context further down. So that new context gets threaded to the next function. So if we look at how maybe retrieve users is implemented, we kind of do a conditional check against the existing context that's come in. If it's undefined, that means that we haven't set any data in there yet. So we attempt to get the data, we return the response. And if it pattern matches out to this underscore users here, that means that we've already got the data in the context and we continue moving on. And then when we look at the toJSON function, we do the same thing. We call this maybe retrieve users wrapper. If we get the data back, we kind of just extract it out of the context. You'll see this here with this new context pattern matched against the users field. We call mochi.json2 in code, wrap it in that weird struct object that's required, and then return the result to the user. And in the case that we can't get that data back, we call mochi.json in code, and we return an empty list of users. So that's kind of like an application specific thing that we handle. So it's very nice. This is very easy to reason about code. It's very easy to write well-behaved HTTP interfaces with this. All the callbacks are really straightforward. You can identify a particular one that might be acting faulty, but like what happens if it's really hard to debug? So I don't have time to go into a lot of this, but I got it on a slide so Sean can talk about it and more, which is the web machine visual debugger. So this is pretty neat. So what you're actually seeing here is a real trace file of a real web request. And as you go, all of those little triangles represent decision points in the decision core, which is what executes those callbacks, takes the return value and examines it, and determines which place to call into next for the next traversal through the graph. So, each area on the, I don't have time to go into this. There's a really great tutorial that me and Sean did at Lambda Jam here in Chicago a few months ago, and we have an example of how to run the debugger. We have an example of a bad resource which will generate a problem in that you actually have to use the debugger to find. So we purposely introduced something where, I forget, we do like a bad pattern match or something, which causes it to go into an area it's not supposed to and ends up returning like a 404. So we have an example. I have a link to it at the end of the slides. You can go run through it. There's a repo you can actually check out where it's fully set up. All you have to do is run make, and you're good to go. So this is a really awesome feature of Web Machine, and it makes debugging where the web request has gone wrong, where you've coded one of those things wrong. So this is really nice compared to like having to debug, you know, like these massive inheritance structures that you see in Rails. You know, you don't have to worry about like tracing something through a view, through a controller, through rack middleware and stuff like this. This is a nice, easy to reason about way to go to debug your code. So 30 slides out of 77. Man, I'm usually fast, and I think I have to pick up the pace. Amazing. So asset management. So asset management's kind of a weird thing, right? So Rails has the asset pipeline. It's nice. It's not awesome. I'm being liberal with nice. There's a bunch of problems, but there are a bunch of nice things that it's there if you want to use it. So you don't get any of this with Web Machine. You don't get this with MochiWeb. There are some things for Yaws and Cowboy that provide abilities to the ability to serve assets like through a middleware piece. So how do we go about thinking on how to handle this? So we built another Web Machine resource that we see here. So here's the code, React CS control WM asset. So we wrote a very small Web Machine resource to handle serving these assets, which actually ended up being really straightforward and not very complicated at all. So this relies on a couple functions. I'm trying to see what the slides are in a weird order, so let's go to this one and then we'll go back. So with this resource exists function that we already talked about, this is the function that's going to determine if you return the 404 or not. So what you have to do is return true or false based on whether the asset exists. So we call this identify resource function. And then we pattern match on the result. So we pattern match on this new context, and we determine if we want to serve up the application template. So the application template is just one file that serves up all the JavaScript assets. Or we want to serve up a file, because that template is going to reference a bunch of JavaScript files. So it's going to reference like an Ember.js source file, a jQuery source file, or something like that. The fav icon. I mean, how are we going to serve the fav icon, right? And this is really important. We actually have a really cool one too. So how do we do this? So if we determine that it's a file resource, we call into file lib, we see if the file's there. If it is there, we return true, we move on. So what does the identify resource function look like? So we come in, if the resource is undefined, so we initialize it as undefined. If the resource is undefined, we look at the path of the web request. So this is what this WRQ dispatch path does. And we see, okay, did they access just the root URL? If they access the root URL, we'll set that resource to be template. If they've accessed anything else, now we need to get the rest of that path. We need to normalize that path based on the file system path. And then we want to say, well, it's a file and it's a file name. So now if we go back here, we can say, okay, resource file name, file name, file name. That gets set to be whatever the file is. So imagine it's jQuery.js. We determine if that's an actual file on the file system. And if it is, then we say, okay, that's true. If not, we say false, and it returns 404. So how do we handle the content types? So same thing, we call this identify resource, which sets those things, those variables. And we say, well, if it's a file, we can call web machine util guess mime to inspect the mime type of that file and then return that mime type. So really straightforward, right? This is not rocket science I'm showing you here. And if it's not, we assume it's text HTML, because we're just making the assumption that the application template is text HTML. To be explicit, that could have been new content pattern matching against resource template. And finally, how do we actually serve that file? So the toResource function you see is referenced here, toResource, so text HTML toResource, MIME type toResource. Do that pattern matching. You've seen this in Corey's example. You saw it in Susan's example. After that, if it's the template, we do some CSRF stuff. We'll talk about that in a few minutes. We have many slides on that. And we render the template. So we just call our template application. And if not, then we just call file, read the file off the file system, return that content to the user. So it's really straightforward. So, this asset pipeline thing, it's not really, serving up assets, rack like file directory. This is not rocket science. This is really simple. This is, I don't know, what, like 75, maybe 60 lines of code, something like that. I don't even know. You can look on GitHub. It will tell you the exact number. So asset management. So how do we go about generating assets, right? So the other part that you get from this asset pipeline is the ability to take a bunch of assets, pre-process those assets, and do things like that. So this is also problematic. So I'm actually not sure, Chicago Boss, maybe when it's talked about later, that actually might handle this. I don't know, because I haven't worked with that framework that often. But we went ahead and kind of home-rolled some stuff to make this work. So let's take a look at what we've done. So the rebar config, we have 2 plugins that we wrote. We actually wrote about 10 plugins, but this application only uses 2 of them. I mean, 5, 6, something like that. The rebar.js handlebars plugin and the rebar.js concatenator plugin. So what rebar allows you to do in the build process is create plugins and have those plugins execute during compilation of the Erlang app. And they can do whatever. You know, we have ones that build beam files from protocol buffers. We have ones that compile Erlang. We have a bunch that we have a concatenator, which concatenates JS files, which we'll look at the config for that. Handlebars, stylus, some other CSS stuff. And there was one other that I don't know. Oh, ugly, like uglifying assets. We don't do that here because concatenating to uglify the assets isn't really a big win for us at this point, but we have a plugin to do it. So what does this JS handlebars plugin look like? So with handlebars, since we use Ember, we actually don't compile the handlebars. We just have to wrap them in closures. So this is just that with this handlebar compile, and then Ember does the compilation. Not as efficient if we compile them and store those, but anyway, it's pretty straightforward. You have a document root, tells it where the templates live. You tell them where you want this compiled code to go out. We have a target, which tells it how to preface the modules. We have a compiler, which is just wraps it in a closure that's got this wrapper around it. And then this template says, this template is a list of 2 tuples, and the tuple says what we want the output file name to be, generated templates.js, and what we want the input files to be. So we say, take all these handlebars templates, wrap them in this closure, bundle it into this file, and voila, works in the build process. So concatenation, very similar. Document root, we have a vendor root, we have an outdir where we want the JavaScript to go. We have these concatenations, so we say, I want one file called vendor.js. I want it to have this jQuery, jQuery UI spin, handlebars, Ember, Ember data, latest, whatever, minispade, all of this stuff. So this is pretty straightforward as well. And you know, we have examples in the README of breaking this out. So maybe I have like a core framework JS, and that's got Ember and Ember data in it. And maybe I have like helpers.js, and that's got the spin and handlebars and minispade or something like that. So this allows you to do this. And as you see, we run rebar, compile, skip the deps, which is just allows me to make the output a lot smaller. And we see hits rebar CS control. All the Erlang's already compiled, so all you see is it compiled the handlebars asset, generated templates. You would have saw the concatenation in there, but that was already done, and I screwed up the slide. So cool. So CSRF protection. So CSRF protection is interesting as well. So this is another thing that with Web Machine and Mochi Web, everybody was kind of hand rolling. So we wrote a version in Web Machine with a bunch of helpers. That's open source and freely available. But this is another thing that you kind of get for free with Rails that you don't really think about, right? Because it's kind of like automatically in the app template. It's automatically in the jQuery that's included to submit the tokens. So we kind of had to home roll all of this stuff. But again, as you'll see when I go through the slides, you know, it ends up being like 40 lines of code. It's not really that complicated. It's pretty easy. So in a Web Machine callbacks call forbidden. You know, we do React CS control security, which is a function we'll look at in the next thing. This is the user resource. We just say is protected. We pass in the request data, and that's either going to return true or false. And we can validate the token there. So if we look at the security module, we have a few functions here. So we have a get CSRF token that takes a request data and a context and returns a token. So what this does is this allows us to get the CSRF token out of the cookies, so out of the browser's cookie, the cookies that have been submitted to the server, and that's a secure token and all that fancy stuff. So the isValid CSRF token gets the request header that's submitted with the token value. It extracts the token out of the cookie and then performs a comparison. So it says, as long as a token has been submitted, so the token is not undefined, so it has been submitted in the header, so jQuery has added that to the header before it submitted the request, and we also validate that the tokens compare correctly, then that we consider that valid. The isProtected method allows us to say, we only want to do this protection on post and put because most browsers are not going to submit a token on get. Pretty straightforward there. That should actually have delete in it too. So yeah, that's a bug. You can file that on GitHub right now if you'd like to, because I haven't. And isProtected is going to just kind of combine these things, right? So it's going to say, well, this is null origin. I'm not showing you, but this is another type of CSRF protection where you validate that the origin has been set correctly by the browser. So you're making sure somebody's not doing a cross-site scripting attack. But really, it comes down to, is the token valid? And is the method protected? And that's it. Like that's what it is. It's pretty simple. And we use early DTL, the templating library, to just kind of write that token in on the request. So if we actually, come on. We actually look here, you see that we say, OK, content, application DTL render. We just generate a token. We substitute that token in. If the user already has a cookie, we continue persisting that value in. So this is like, this is not, but I can do it faster with this. This is not very new. It's pretty straightforward. All right. Good. Okay. So that kind of talks about the application. So now we're going to kind of talk about the Erlang ecosystem that kind of lives around it, that provides a lot of benefits. We'll talk about testing, and we'll talk about deployment, and then it'll be done. You guys can listen to the rest of the great speakers we have. So there's eUnit. eUnit's okay. If you like writing unit tests, it's okay. Hopefully Susan's already convinced you to not do that and do property-based tests. Maybe. eUnit's similar to test unit. It's going to be similar to mini-test if you don't use mini-test with if you use mini-test regular, not mini-test spec. So it's very similar in here. We'll just look at a test, length, we assert. It's a pretty awesome unit test, actually, right? I mean, that is pretty versatile. Put that in a lot of applications. They probably got that test. I took this right from Erlang.org, so it's probably somewhere in the beam too, I bet. Steve probably wrote this code. So let's look at something a little bit better. Fibonacci, pretty straightforward here. We've seen, a bunch of Fibonacci examples today, so you should be really well versed. This is kind of like the functional programming hello world. We just assert that some things have worked correctly. So not really anything complicated there if you've ever written a test in your life. Sweet. All right, cool. So the dialyzer. So I missed a couple of the talks today. So did somebody talk about the dialyzer yet? No. Garrett did not talk about the dialyzer. Nice. So dialyzer is dialyzer arguably is one of my most favorite parts of Erlang. I love the dialyzer. I run dialyzer every day. I run dialyzer for fun. I read dialyzer papers when I'm whatever, drinking a beer, I ride my bike and listen to dialyzer podcasts. This is what we're talking about. So what is the dialyzer? So the dialyzer is a discrepancy analyzer. So if you imagine if you convert the letters to uppercase and take all the lowercase out and combine it, you can get the word dialyzer from that. I bet there's only 5 people who know that that's what that means. So how does it work? So it's based on this concept that comes from this paper that was written in I don't even know, 2000 something, maybe even earlier. So it's based on this concept called success typing. So Erlang is a dynamically typed language, right? But Erlang does have about 8 primitive data types. So you have atoms, you have you have terms which are any Erlang term. You have atoms, binaries, references, PIDs, all of these things. But it's about 8 or so, I think, 8 or 10 basic data types. So what you can do is you can do analysis of a program and generate, if you imagine the data types as a lattice, and the type that represents the most generic type, term or any, is at the top of the lattice, none is at the bottom of the lattice. You can imagine that you can perform an entire program analysis by building a call graph and examining the strongly connected components, and then do type analysis, even though we don't really have a type system, a real ML style type system. And it will allow you to generate these success typings. So the success typings tell you a disjoint union of calls into that function that will pass, that will definitely not fail, but it can't guarantee that calls in will definitely always succeed. And it will generate return types. So what does that allow you to do? So here's an example, and hopefully this wows you. If not, then you can come tell me that my hobby is terrible and that I should go read like Lord of the Rings instead of dialyzer papers. So anyway, we have a module called tests, and we have a compile export all because I was lazy. And what we do is we have a check function, which calls this isOK function with the atom OK. And then we have this isOK function, which takes a symbol, and then it pattern matches on the symbol. So it pattern matches OK and any, returns true, and pattern matches error and returns false. So imagine that you were like, I don't need to test this because I am so awesome that I never write problems in my code. And then you run the dialyzer. So dialyzer has to build this PLT. We're not going to get into that. You can read all about it. You can wait for it because it takes a long time. So what it's telling us is that if you look at line 14, ignore that no local return thing for now. You can look at line 14. It's basically going to tell us that this isOK function will never return because it differs in the arguments. So it can do analysis and tell you that, this pattern match is going to do OK or error. The caller into it is not a tuple, so it won't return. So this is incredibly powerful. And this catches a lot of bugs. And it catches a lot of stupid bugs that you make as a programmer. So this is great. Imagine if Ruby had this, something like this. So, and there's a bunch of research happening on dialyzer. The most recent is that some of the closure core type stuff is going to start like kind of looking at this idea of success typing. Success typing is a pretty kind of new thing in PL, reasonably, if you look at the entire history of PL. So that's really awesome. So hopefully I convinced you. I mean, with this really trivial example that I wrote in like 2 seconds to fit on a slide. So anyway, QuickCheck. So Susan talked a little bit about QuickCheck. There's also proper and whatever the trifork one is called, trick. So QuickCheck you have to pay for. It's written by John Hughes' company, QuickCheck. Proper is an open source version that comes out of Uppsala University. It's GPL licensed. And then, so you have the pay one, you have the GPL one, and then there's the trifork one, which is BSD licensed, but not no? What? It's Apache. So you can take your pick based on whatever you want to do with your company. If you want to give your company to Richard Stallman. But no. So property-based testing utility. So what does this look like? So let's take an example. So I'm not going to go like really into this because, Susan already did it. I'm glad she didn't use the example that I have because that would have made me feel really dumb. So anyway, for all. So we're going to kind of just say, this is pretty simple. We write a property that says, given a list of integers, if we, take that list, we reverse it twice, we should get the original list back, right? So that this should be true. This should be pretty simple, and you should be able to reason about what this does. So, we can quick check that. And it passes 100 tests. You can tell it to run more. You can tell it to run for 30 million days if you wanted to see if this function always holds true over all of time. And it will until whatever happens, the singularity or something. So the delete property, how does this work? So let's look at this. So did I do the right one? Did I take the busted one? Yeah, I did, right? Yeah. So what we do is we say, given a non-empty list of integers, and we get an element of that list. If we delete that item, it will no longer be a member of the list. Seems like it should be true, but it's not. So here it's going to show the inputs. So there's one's the item it's checking for. There's your list. So obviously it does fail, right? Because we've already determined that this list delete function only removes one instance of it and not both. So the item's still a member and it fails. But where does QuickCheck excel? With the shrinking. So the shrinking is arguably the most powerful part of QuickCheck. It's going to take that list, it's going to produce it to the minimal failing test case. So here we see the minimal failing test case is 1, 1, and 1. So this is such a trivial example that, it's not going to blow your mind. But you can imagine that if you're testing much larger functions, much larger applications, that this is pretty amazing. And what was with that rogue slide? Oh, because I wanted to show you the bad code. There's the bad code. Deployment. What do I have, like 12 minutes? So deployment, 5. Oh my God. So deployment, what do we have? So rel tool. Everybody's complained about rel tool. I'm not going to say it's really awesome, but, we've gotten pretty good at making it work at Basho. And so this allows you to build like a standalone Erlang release. It's got the runtime bundled in. That's really nice. This is how we ship React. This is how we ship React CS control. This is how we ship all of those things. And if you combine this with Node Package, which is another Basho product that we've put together, see, we've had to build a lot of this tooling. This is kind of the unexpected journey, even though it was expected. We have this ability to build packages that we can ship to all these platforms. So Solaris, SmartOS, it's got the startup scripts bundled in and everything. So that's a really nice solution to getting your application deployed. Similarly, Hype. A lot of people don't like Hype. I think Hype's pretty cool. Hype is actually how Dialyzer is so fast. So Hype is basically high-performance Erlang. It does native code compilation of Erlang modules, and we'll load that code in. Dialyzer does this to get speed increases when it does the analysis. So when you run Dialyzer and you see compiling to native code, that's all done through Hype. If you don't have Hype enabled and you run Dialyzer, you're going to wait for a very long time. Very long time. Similarly, Heroku, Tristan's here. He can tell you way more about it than I can, but there's a build pack. It's Git, if you don't know Heroku, it's like you deploy through Git. The build pack's really nice. It allows you to install all of your dependencies through Rebar, get your whole application running. We also have, for the tutorial that me and Sean did at Lambda Jam, we have an application that's deployed to Heroku. It's all set up to go. There are a couple weird little tweaks that you have to do around like the code paths and like the things like that to make sure that some of the stuff that needs to write can be done on like the ephemeral storage. So there's like few little hacks, but you run into them really quickly because your app fails to start. But anyway, we have a bunch of examples of this. So this is really nice to deploy. If not, you can use Node Package to build a tarball, send it to a server, use the init script, make it run with Upstart or Matt Damon tools, whatever you prefer. And DSU. So DSU, Dynamic Software Updating. This is really cool. This is actually a really hot research topic right now. Erlang's had it for a really long time. Did I knock this off? No. So this allows you to do hot code loading, and allows you to control the upgrade point. So in the Erlang VM, you can have multiple, you have multiple processes running. Each of those can be running a module at you can have 2 versions of a module loaded in the system. The process can be running different ones. If those are like tail recursive processes like GenServers that run forever, you can control the point where you want the upgrade to happen. It allows you have a bunch of callbacks to handle how you transition state if you have records or things like that that are held in state that need to change. So this is really cool, and this is a very unique feature that you should take advantage of if you use Erlang. It is non-trivial, that is for sure. So the conclusion. So what did we learn? We made an application that was a lot smaller than a Rails app, a lot smaller. Even with all the dependencies, still probably an order of magnitude smaller. It starts faster, it runs faster, it stays running all the time. The Erlang VM is really nice. It's really fast. It's very reliable. The whole supervision tree that I'm sure you've heard a million times already today is really great for keeping applications running. But what were the problem areas, right? And there's this lack of tooling. It's a trivial solution to solve, and we've shown that like in 60 lines of code, we were able to get CSRF protection going. We were able to get asset pipeline happening, and we were able to write these really small web resources that are very compact and easy to reason about what the behavior is, and have nice tools to debug them. So, you have to really think that when you're making the choice. It's a question of, do you want to use a platform that's kind of built for this like high availability, fault tolerance, or you have to balance that with, do you want to take advantage of a lot of these existing tools? But the main thing I'm trying to show here is like, don't be afraid that the tooling doesn't exist, right? It's really easy to make. And it's really straightforward to get your application off the ground. So in conclusion, the man himself. You got to try Erlang for your next project, and feel free to hit me up on Twitter. I'll tell you all sorts of things that are amazing. And here's the application. We have a bunch of applications. Here's a tutorial, and yeah, that's it. Thank you very much. Questions?
You said run to produces standalone executables. Does it do?
No. I was saying that you can bundle your entire application up and ship the Earth with it, the Erlang runtime system.
Oh, okay.
Yeah, no, not like you can't do. Not that I know. I know some people have asked about it, and some people are working on it. There's no way to do like native code, like build a binary, as far as I know. That's an interesting project. Should write a paper on it. I'll read it. Okay. Thank you very much.